Hello everyone, my name is James Esparza, and today I'm going to be giving a recommendation report on electric versus hydrogen vehicles. Now, to give a brief overview of the presentation, I'm going to be first stating how either vehicle works, then going into the scope, then including the results and my final recommendation. So let's begin. Electric vehicles, what are they and how do they work? So electric vehicles, or EVs for short, make up power by utilizing the electricity stored in its batteries. These batteries are typically charged by an outside electrical source. And to the right, you could see a diagram that includes the parts and how each part interacts with one another. Next up, we have the hydrogen vehicle. Now, this vehicle makes power by utilizing the hydrogen in its tank. The hydrogen is fused chemically with oxygen and creates both water and electricity as a byproduct in the fuel cell stack. As you can see, the diagram on the right contains the diagram for a hydrogen fuel cell vehicle. And if we compare the two, they are extremely similar. They both work nearly the same mechanically. So for the scope of this presentation, I decided to evaluate both vehicles on three criteria: the long-term financial costs, the availability of infrastructure, and the environmental impact of either vehicle. I'm going to go into detail about these later on in the presentation. So first off is the long-term financial costs. As with any typical vehicle, the first thing a consumer considers are the cost of fuel and the general maintenance. For cost of fuel, there is a lot of calculations and data that's needed to be interpolated in order to get a result. On the right, you could see a table named MPG equivalent of alternate fuels. This table was provided by the Department of Alternate Fuels and lists the energy equivalent for 1 gallon of gasoline. This is necessary in order to provide a neutral baseline for either fuel. When doing the calculations, we could determine that the electricity equates to a cost of $4.04 per GGE, and hydrogen roughly costs $14 per GGE. Once again, GGE being the gasoline gallon equivalent. For general maintenance, both vehicles require almost little to no repair or replacements. But if we were to consider the worst case scenario, in which case the battery or fuel cell stack were to give out and need to be replaced, the electric vehicle battery replacement will cost roughly $200 per kilowatt hour capacity, and the fuel cell stack would cost roughly $50 per kilowatt hour capacity. Now, for reference, a typical vehicle will use about 30 kilowatt hour capacity battery. So, with taking this into consideration, you could use that ratio in order to find the replacement for a particular model of either vehicle. This is just the general vehicles. Next up, we have the availability of infrastructure. And what I mean by this is the access to charging or refueling stations. So in the year 2016, the US Department of Energy recorded 58 hydrogen charging stations and 17,892 electric charging stations. This is a vast number difference between the two. For hydrogen, I think the reason behind this is that hydrogen itself is a very reactive element, and when stored in its most efficient state, which is gas, it becomes highly pressurized and dangerous to travel across long distances. For electric stations, they typically have multiple units per station, and this isn't including private stations that you could find at home. Nearly all sockets found in a common household are 120 volts and can be easily converted into a charging unit itself. When factoring in all these facts, you could tell that there's an astronomically higher availability of infrastructure to electric vehicles than there is hydrogen. Now, for the environmental impact, Specifically, I'm going to be considering the CO2 emissions of either vehicle. Now, the interesting thing with this is that both vehicles have a near zero direct emissions, which means that there's almost zero emissions coming from the tailpipe during use. But in order to solve this, I'm going to be looking into the life cycle emissions, which means the emissions during the fuel production, distribution, and vehicle production. So for electric vehicles, the production of electricity causes roughly 99 pounds of CO2 emissions per kilowatt hour. And for battery production, it's nearly 242 pounds of carbon dioxide per kilowatt hour battery capacity. Um, Over time, this adds up to a lot, knowing that the average is 30-watt kilowatt hour capacity. For hydrogen vehicles, the production of hydrogen comes from two different processes: methane reforming and electrolysis. 95% of hydrogen comes from methane reforming, and 0.26 pounds of CO2 emissions per kilowatt hour is a result of this. For electrolysis, it has a 55% efficiency, which means that proportionally it would be 1.8 pounds of CO2 emissions per kilowatt hour. And the reasoning behind this is because electrolysis requires electricity in the first place in order to operate. So you would input 1 kilowatt hour of energy and only get 0.5 kilowatts of electricity out. So now onto the results. For the results, you could see a graph, a table listed with the criteria and the type of vehicle. Hydrogen is considered more environmentally friendly, and electric vehicles are considered better in the long term for financial costs and availability of infrastructure. And you may be wondering what my final recommendation for this is. I'm going to be recommending the electric vehicle. It's better in terms of long-term financial costs and availability of infrastructure, but mainly because the hydrogen vehicle is not stable enough yet to become sustainable. The electric vehicle right now is just stable enough and where it could work in the long run and be mass produced. So next up is my image of references. And if you have any questions, comments, or concerns, please let me know in the comment section below and I could address them. Thank you for watching, and I hope you have a good night.